UVM test bench architecture. In that, so UVM sequence item example. What is the reason we are selecting the sequence items? Okay, so this file demonstrates that, okay, what is the sequence item, and then it will represent that. Okay, just wait. So this file demonstrates UVM sequence items for simple memory transactions. Whatever the simple memory transactions we are considering, that will tell us about it. Okay, so that is the use of sequence item. Okay, so then in sequence item we are transferring the signals, right? Okay, we are generating the stimulus. Okay, so in the sequence will generate the stimulus, and then sequence item will carry that one. Okay, see, the sequence items represents a single read or write operations to the memory. Okay, this sequence item, whatever the example we are explaining, that sequence item will tell us about that single read or write operation to any memory. Okay, so that is the basic operation we are explaining here. See, what is the import package? Okay, whatever we are taking, we need to import the package. Okay, UVM package is the inbuilt method. Okay, so then import UVM package, and then tick include UVM macros.svh. Okay, we have registered the classes, right? Tick include tick UVM, sorry, tick utils component, or tick utils object. So that is the factory registration by using macros. Okay, we need to include that macros.svh. Okay, after that, see, why we are taking the type enumerated data type means enum data type. Enum data type is a named storage values. Okay, it will store that named constant values. Okay, so whatever the named constant values we have, so that will be stored. What is the use of type def? Type def is a user defined data type. Okay, user can define any data type. So here enum is a data type, so that can be user defined data type def. Okay, in the type def we are mentioning that two modes, write mode and read mode. Okay, so what is the write mode and what is the read mode? Okay, why I'm not getting today? Yesterday we got right. So that is the read or write operation. We are mentioning the mode. Okay, what type of mode we are operating? Okay, see, so this is the class representation, class example transaction extends. Okay, UVM UVM sequence item. Okay, UVM sequence item is the parent class. From that we are extending the child class example transaction. Okay, see, these are the fields, transaction fields. Okay, what are the transaction fields we have? Okay, those fields we need to represent here. Okay, so then all are randomized, only inputs. Do not randomize the outputs. Okay, see, so rand transaction. Okay, rand transaction type. Okay, that is the transaction type we are using. Okay, transaction type is the handle of what? Your type def. Okay, that is used in your class. Okay, again I'm taking the another class. Okay, so handle, that is transaction type. Okay, transaction type, it will tells that either read operation or write operation. Okay, and then rand bit address, it is a 32-bit address bit. Okay, it will store up to 2 power 32 values. Okay, and then this is the memory address. Why it is, if I am highlighting that, okay, fine. Again, rand bit data. Okay, so data we are taking, so that data is also 32 bit. This data will write the data. Okay, we are writing the data into the memory, and then same data we are getting. That means reading the data from the memory. Okay, so byte enable. What is the use of byte enable here? Okay, byte enable is a different what type of bytes we are enabling. Okay, it is a 4 byte. Okay, 4 bit. So that means byte enable is a 4 signals we are taking. Each byte it is storing 8 bits. Okay, so 32 bit data we are taking timestamp when the transaction is completed. We need to know that. Okay, that is the use of timestamp. And then after that, what we need to represent class, and then class registration. Okay, is that registration is there? Okay, we need to register the class, right? Okay, so here we are using automation macros. Okay, because each fields we need to register individually. Okay, that's why automation macros we are using. See, register this class with what is that class with factory and provides field automation. Okay, so that is the registration. How we are registering? Take object. So take object, it will begin. And your class name, what is your class name? Example transaction. Okay, example transaction is your class name. So take field. So first type is enum data type. Okay, that is the transaction type. And then the field name is also handle is transaction type. Okay, transaction type is the enum handle, and then transaction type is the class handle. Okay, that enum handle we are represented in our class, that is the handle of transaction type. All on, so it will applicable for all. Okay, and then take field int address we are mentioning. So next one is address all on, and then it is represented in hexadecimal code. It will print it on hexadecimal code. Okay, and then data also all on hexadecimal. Again, byte enable, read data, response. Okay, that's it, right? These are the fields. Okay, all the fields we are registered. Transaction type, address, byte enable, and then read data. Okay, so response. Okay, okay, response. And then timestamp we are not representing. That means just for time, what time you are getting that. Okay, after that we need to represent constraints. Okay, why we need to take the constraints means we are restricting the randomized values. Okay, so address is 32 bit, right? So to for 32 values it will be generating. So now I am setting some constraints. See, constraint address to be word aligned, and then he is saying that last 2 bits, that means lower 2 bits will be 0. Okay, so then address of lower 2 bits means address 10, that means 2 bits. Okay, least significant bits should be 0. We want to represent that. Okay, so in that way he written one constraint. And similarly, their valid address we need to send to the memory. Okay, so then I am setting that. So my address inside the range from 32 tick hexadecimal, all zeros to 000 FFFF. Okay, so that is the address range. In between the range only I need to send the address. Okay, and then so enable byte enable, so at least one bit we need to set, because so it is a 4 bit, right? So 4-bit byte enable. In that, each and every bit we need to set the one. Okay, every time one bit need to be set to one. That means valid byte data you are sending or not. In that way, we need to know that. Okay. So then after that constructor. Okay, function new, string name, and then string name is what? So example transaction. Why string name only is there? It is a object. Okay. So this object, so that's why only class name only we are representing. There is no UVM component parent. Okay. Super dot new name. Okay. So this will be getting the parent data. Okay. And then response OK equal to 0, timestamp equal to 0. So we are initializing that whatever the not randomized fields are there, right? So then I'm setting the timestamp equal to 0. So we already set the value of randomized value of response OK. Okay. So then response OK is a single bit representation. That is the bit we are taking. If it is OK, 1 means okay, my transaction is completed. If it is 0 means still I am doing the transactions. Okay. So that is the custom constructor, and then these are the custom methods. Okay, so I am using function is read. That means whatever the enum data type we are taking the handle, right? Transaction type is the handle of my transaction type e. Okay, so that handle I am representing here. Okay, that equal to read. That means it will do read operation. If it is equal to read, that means transaction type handle shows that read, then it will do the read operation. That means getting the data from the memory. Okay, and same, check if this is write transaction. Okay, similarly, I am doing the write transaction. Return function bit is write, and then return type is the write operation. That means handle is equals to write, then it is doing that write operation. Okay, then so this is the conversion. Okay, convert transaction to string for debugging functions. Okay, say function string convert to string. Okay, so this is my function and name of the function is string. Sorry, by a integer type is string. Okay, variable data type is the string, and then my name of the function is convert to string. Okay, then string s is the string name. Then s equal to $s format f, whatever the transaction we are considering, transaction percentile s, this is the new line, and then transaction type dot name. Okay, so what we are taking, so name is the read or write operation, it is doing that. And again address. Okay, 8 tick, so 0x percentile 0h 08h. Okay, so that means your address is storing 8-bit values. Okay, and then new line data. Okay, sorry, address. Similarly data. Okay, so hexadecimal values it will store up to 8. Okay, and then read data. Similarly, $s format s comma s format f byte enable, that is 4 tick, right? Okay, so 4 tick, so percentile 0b, 0b percentile 0b, 04b. Okay, then byte enable. After that, so if response is okay, then it is the taking conditional operations. If it is okay, then my response is okay. Otherwise, I am getting some error. Okay, so again some custom constraints to create directed read transactions and then directed write transactions. Okay, so we are setting that some address equal to address, data equal to w data. Okay, so same thing, address equal to address, and then tab transaction type equal to read, and then I am reading the data. If you are not writing the data and then reading the data is 0. Okay, if you are writing some data, then w data will be setting some value. Okay, so that is the read operation. And do compare, so that is the customized, manually we will write the code. Okay, comparison operation it will do that. Okay, how it will be doing? Function bit do compare, and then your object is RHS. Okay, handle is RHS, and then UM comparator, comparer, and then comparers. Okay, compare, comparer. Okay, so UM comparer, and then example transaction is the handle of my class. So class name, and then handle is RHS transaction. Okay, so then bit status equal to 1. Okay, so bit status, that means it is 1 means it is doing some operations. Okay, then dollar cast, we are casting that. So RHS is the source and destination is that RHS dot RHS transaction. Okay, so whatever the RHS handle having the data, that will be converted to RHS transaction. If we are not converted, and then error we are getting that. Okay, so then status, so status and super dot do compare RHS comma comparer, and then so and then transaction type equal to RHS transaction dot transaction type. Okay, so it will compare that both are equal, then it will do that read operation or write operation. Okay, so is right, it will do that write operation, so putting the data, and then status, we are getting that byte enable equal to whatever the data we are writing, that will be stored in the byte enable. Okay, so this is the do compare operation. So sequence item, if it is, these are all optional. If you want to write, okay, you can write, otherwise where we need to start, so just a class registration, and then some constraints, some data fields we are representing. After that it will be stored, register for individual macros. That's end class. Okay, class registration, data fields, and then custom constructor. After that some automation macros registration, individual macros we need to represent register. After that end class, if you want to write any constraints, you can write. That's it. That is the sequence item.
So
Okay.
in that we can put up some customers
Hmm.
in that we can convert the transition data into
Read
the
operations or write operations, we are doing that. Okay,
okay.
so you are saying that, okay, you need to do some read operation, or you are saying that it is there, it will do some write operation. After that it will store the data, so string format we are converting. Okay, so and then $s format f is used to store, convert the data formats. Okay, then sequence, UVM sequences. Okay, sequence will generate the sequence items. Okay, so that means transactions. Send them to driver. Okay, whatever the sequence items generated by the sequence, okay, that all are sent to driver. Okay, so they define the stimulus patterns and test scenarios. So depends upon the sequence items. We are saying that, so different sequences we are writing. Read sequence we will write sequence we will read write sequence, continuous read, directed write, continuous write. Okay, so continuous write read operations, all these things we are writing. See, class, example, so base class, so example, base sequence. That means we are extending the UVM sequence. So this is parameterized class. Hash example transactions. That means whatever the sequence items we are represented in the upper class, okay, that will be connected here. Okay, so parameterized class we are considering. Okay, hash example transaction is the parameterized class. And then class registration, tick UVM object utils. Okay, so and then example base sequence. Okay, that is my class example base sequence, that is my class type. After that constructor, function new, string name, that is the example base sequence. Okay, so this is my class name, there is no UVM component parent. Okay, this is the object, right? And super dot new, only name. So name comma parent is not represented. If it is name comma parent means we are that is for components only. Okay, so object there is no parent. Okay, so pre-body method, that means execute before the task body method. Okay, in the task body method, so in the pre-body method, so virtual task pre-body, it starts that. Okay, so phase rise and phase drop objections which will be start. Before that, I am representing my starting phase is not equal to null. That means at least one value we will represent that. Okay, begin starting phase, that means dot rise objection. So this comma starting sequence. Okay, so this is the description and this is the id. Okay, this means for this component we are writing that. Okay, end component and the task. Okay, begin is ended and then task is ended and the task pre body. Similarly, post body method also we are writing, and then in post body method we are stopping the rise objection. Okay, in between the pre body and post body we will execute the task body method. Okay, so this is the base sequence. It will do nothing, just we are doing some rise objection and drop objections. Okay, so after that we are writing sim. So pre-body and post-body, if you are not considered, that is also fine. So before that, in the task body method only, we need to write some phase dot rise objection and drop objections. So pre-body, post-body methods are there, right? So that's why I'm in pre-body method, before task only, I'm rising the phase. Okay. So before that, if you raise the objection and then it will end the drop objection. Between that, if you start any sequence, then you can write the sequence in between the rise and drop objections. Okay, so that's why pre-body method and post-body methods we are taking. If you get confusion, the pre-body method and post-body method, you can write the rise and drop objections in the sequence body method only. Okay, see what we are writing: simple random sequences. Okay, so simple random sequences, that means n random transactions using constraint defined in the sequence item. Okay, whatever the sequence item constraints we are represented, okay, same way we need to generate the n random transactions. Okay, so simple random sequence. So in this simple random sequence what we are doing, so just it is doing the write and read operations. Okay, simple write and read operation. Say class simple random sequence extends you example base sequence. Okay, base sequence is the example base sequence is the child class. Okay, this is the child class, right? So and then UVM sequence is the parent class. From the child class I am extending another class. Okay, so that is the example base sequence is the child class. In that, here I am extending another class, that is simple random sequence. Okay, so then register for that factory registration, register with UVM factory. Okay, that is pick UVM object details simple random sequence. Okay, so in this what is the base things we are doing here? N random transactions it is doing that based on the constraints. So we are written the constraints number of transaction, that is inside 5 to 20. That means in between the 5 to 20 only we are generating the transactions. Okay, so in between the number of transaction it will be generating sequences only. That means 5 to 20 means approximately 15 sequences it will generate randomly. Okay, and then custom constructor function new string name simple random sequence new name and then end function, that is ending the new function. Again, so in task body method, so what is your class name? Example transaction handle I am considering. Okay, for that I need to create the memory. Okay, so generate and send number of transactions random transactions repeat. Okay, so it is generating the number of transactions. Okay, how many times you are repeating? Number of transaction times. Number of transactions, what is the value? 5 to 20. Okay, those many times it will be repeating. For that, I am creating the new transaction. See, transaction, example transaction, type ID, create transaction. After that, start item. That means wait for the sequencer to ready to accept these items. Okay, sequencer will send the request. Grant to whatever the request sent by the sequencer will grant that sequence. Okay, so then if it is granted, start items of transactions. That is your handle. Okay, randomize the transactions. How we are randomizing? If not randomize, not transaction dot randomize, we will get some error. If it is randomized, means it is passing that. And then so print that info, get the type name. So $s formatted. I'm converting that strings. Okay. So height. So we are taking the verbosity level. And then finish item. Get response is an optional, right? Driver will send the response, or otherwise it will be stopping there. Item done, it will be sending. Okay. So this is the basic simple transaction. So just randomizing the transactions depends upon the address. Okay, understood? Directed write read sequence. See, perform direct write followed by read in the same address. Okay, and then useful for basic memory functionality testing. Is that working fine of your memory? So it will test by using this one. Okay, so just see this. See this transaction, how it will be doing that means, okay. So what we are considering, we are considered two constraints in sequence item. That constraints working fine or not, we are testing here. Okay. So class registration, class write read sequences extends example base sequence. Okay. This is my class name. Okay, extending from same base sequence. Okay, so example base sequence only we are extending the class. Okay, similarly class registration, pick object details, my class name, write read sequence. And then configuration parameters, you're testing the address, then test address I am considered, and then you're testing the data, test data I am considered, and then how many iterations you are done. So number of iterations I want to do it. Okay, the iterations will be in the range of 10, 1 to 20, 1 to 10 only. Okay, if you want to do number of iterations means, so how many transactions it is doing. Okay, so write read transactions, one write, another read, write, read. Okay, one transaction, write operation, another transaction, read operation, again write, read. So in that way, I am considering number of iterations. One iteration it is doing the write operation, other iteration it is doing the read operation. Okay, so we have considered that random test address is in the range of 2 bit. Okay, last 2 bits, that means least significant bit should be set to 0 for word aligned. Okay, and then test address inside in the range. So we have mentioned already constraint 0 to FFFF. Okay, so then the custom constructor function new string name, your class name. What is the read write read sequence? Okay, write read sequence your class name and super dot new name end function. Same. Virtual task body method. In that body method, your class handle. Okay. Example transaction, write transaction, comma read transaction. Okay, two handles I have created. For that, we need to create the memory for that. Okay, if it is created, tick info get type name $s format string write read sequence with percentage 0d iterations. Then number of iterations it is doing that. Okay, and then verbosity level is medium. So how many times it will be repeat depends upon the number of transactions. Okay, begin, and then this dot randomize. Okay, so for this sequence only we are randomizing them. If it is not randomizing, we will get the error. Okay, and then sequence randomization failure, then we will get zero output. If it is randomization failure means we will get the zero output. See, write transaction. For that, we need to create the object. Okay, so write transaction, example transaction, type ID, create write transaction. After that, start item. In that, what we are testing, the data is setting or not. Okay, write transaction, set write transaction, test address comma test data. Okay, whatever the test address and test data we are having, that is we are checking that. Then write transaction dot byte enable equal to all four ticks. Okay, four tick B111. So that means all bytes are enabled, not only single byte. Four bytes are enabled. Okay, so then it will store the data as well as test address and test data. Okay, finish item write transaction. So in between the number of transactions, those many write operations it will do. Okay, so then read transactions. We are writing the data, right? Okay, that data we are getting. So simply previously we are giving address as well as data. Okay, so test address and test data we are also giving. Now only address we are giving. Okay, so read transaction, set read transaction, test address. Okay, if you give the address, then it will get the data. Okay, same. So start item and then create the memory. Okay, so object creation. After that, so how we are creating the object, read transaction, example transaction, type id, scope resolution, create read transaction. Okay, this is the syntax for creating the object. After that, start item read transaction. And then so directed method to set the read transaction, that means we are doing read operation, whatever the write operation we done, same read operation we are doing here. Okay, so test address we are setting that. And then read transaction dot byte enable equal to 4 tick B111. Here also all bytes are enabled, that means any byte data it will read the data. Okay, then so it will convert that data. And then finish. So tick info get type name $s formatted, read, so address and then test address. After that, finish item. So in real test bench, the scoreboard would be verify that read data matches with the write data. Okay. So what we are doing here, this is the one sequence, write read transaction we are doing. Whatever the data we are writing, same data we need to get that. In scoreboard, we are testing them. If you are writing the data and then reading the data, both are same. If your test is passed, okay. Otherwise, the test is failed. Okay. Take info get type name $s format completed write read pairs number of write transactions. How many transactions it is doing that? Okay. What is burst transaction? So burst transaction means, so single address we are giving, multiple transactions we are doing that, right? That is the burst transactions. Okay. Now generate burst of consecutive memory accesses, useful for testing memory, but burst transfers. Okay. So then class burst sequence extends example base sequence. Example base sequence, we are extending the sequence. Okay. So take object details burst sequence. Class name is burst sequence. Same NAND bit, base address, burst length, burst type. Okay, so base address or start address we will give, and then burst length and burst type. That means increment burst or fixed burst or wrapping type burst. Okay, that is the type. And then burst length inside in between the 4 to 16. Okay, so the length we are mentioning that in between the length only, in between the 4 to 16 only it will there. And another constraint for base address. Okay, the base address we have mentioned, right? Okay, what is the base address we have mentioned? So 00, last two bits, least significant bit should be 00. That is for word aligned. And then base address inside the range. So all F's we need to mention. So this address is also there. Okay, so that is the thing we are testing that. Okay. See here, constraint base address. So address we have given, and then custom constructor. Okay. So function new string name burst sequence super.new name, and then end function. See the main sequence logic we are writing here. See virtual task body example transaction we are created, and then current address we have taken. Okay, so it will store the data. So string formatted. Okay, starting a percentage s burst length, that is percentage 0d, and then so see here address from address 0x percentage 0h it is starting, and then burst type name. So this is the string name burst name we are printing, and percentage 0d, that is the burst length, and then address, so base address we are taking. Okay, that is the information message we are writing, and current address equal to base address. Okay, see how we are sending the transactions based on the burst length. So for I equal to 0, I less than burst length, and I plus plus. Okay, up to the burst length it is reaching, it is in between the 4 to 16, right? Up to 16 addresses it is reaching, then this loop will be repeating up to the 16 addresses. Okay, 16 length. Okay, burst length is 16. Transaction equal to your class name, example transaction, type id, create $s format of transaction percentage 0d I. So I means, so I equal to 0, so 0 less than burst length. If it is 4, okay, 4, 4 in between the 4 to 16 it is there. Okay, so if it is 5, you can take 5 transactions. Okay, I will be increased, and then start item. Okay, start item, and then transaction type is burst type, and then transaction dot address equal to current address, and byte enable is a 4 bit. Okay, whatever the data we are considering, that data will be stored here. And then if burst type equal to write, okay, it is doing the write operation same, that transaction dot data equal to current address plus I. Okay, so whatever the current address we have considered, that address and then I value will be taking. Okay, depends upon the I value, based on the length it will be doing the data. Okay, transaction data, and then it will store the address and then data, as well as I value, which value we are doing that. So which length, so 5 or 6, 7, depends upon their, we are giving randomly. Okay, in between the randomization inside the range we are giving, right? And then transaction dot data, if it is fail means, so the data will be 0, and then it will store that data as well as reading the address. Okay, which data, so if we are doing the write operation, okay, if it is fail means it is reading the data. Okay, read operation it is doing here, write operation is doing it here, read operation we are doing. Okay, if it is not right, what it is doing, read operation, and then finish item. Increment the address by word size is 4, right? So depends upon the word size it will increase. Okay, and then complete the transaction, it will print that completed the burst sequence, and then number of transactions, how many transactions it is doing, it will print that. Okay, so same thing, constraint random sequences. Okay, so just check this constraint random sequences. Okay, class registration, number of transactions, same thing, task body. So we are getting the transactions and doing the write operation. So 70% write operation, 30% read operation, distributional constraints they are considering. After that, address inside the range, some 002 7FFF. Okay, up to that it will be doing that, and then byte enable also we are giving some data. Okay, 111 1100 0011 different combinations he is giving that. Okay, that is the what is the sequence name here, constraint random sequence. Okay, similarly, um, nested sequences. Nested sequences means how to create complex test scenarios by combining the sequences. Okay, so that is the nested sequences. Okay, so same, write read sequence, burst sequence, simple random sequence, whatever the sequences we have created previously, all the sequences we will do in here. In the phase one, random warm up transactions it is doing that. Okay, how it is doing, so create item, and the number of transactions 5 depends upon the sequencer handle. So M sequencer is the handle of physical sequencer. Okay. Okay. Hmm? M sequencer is the handle of physical sequencer. So whatever the sequencer we have, right? For that we are creating the handle. Okay, it will create default. Okay. So based on that, it will do that different sequences. See, where we are representing M sequencer handle. So task body here we are writing. Okay. So rand start. So sequence dot start M sequencer. Okay. Sequencer only we are carrying the sequence items. So then we are starting the sequences. Okay. So for that, based on the handle, it will get that data. Okay. Same burst sequences and then read burst sequences. Okay, all the sequences it will be completing in the nested sequences. Okay, so group of sequences we are executing here. So that is the sequence. Okay, same thing here also there. Okay. Okay, so this is the sequence item where we are representing class registration. So class extension of class from sequence item, that is the memory sequence item. And then class registration tick macros. Okay, utility macros we are registering the class. And then custom constructor function new string name memory sequence item, that is your class name and function. Okay, and then after declaring the fields in the memory sequence item. How we are declaring the fields? Class again, class name, okay, extends from sequence item. And then fields, I am doing some write address, write enable, read enable, write data, read data. Okay, W data for write data, R data for read data. So here also we are doing some memory transactions. Okay, same class registration, custom constructor. In this, what we are representing? Fields. Okay, so declaring the fields in the memory sequence item. Okay, after that we are randomizing the fields. Okay, to generate random stimulus, declare the fields as a random. Okay, rand keyword we are using. So that is the rand bit address, rand bit write enable, rand bit read enable, rand bit write data. Why we are not randomizing the read data? Read data is an output. Okay, that is not randomized. Input only we need to randomize. So same thing, remaining things all are same. Take object details, class name, class registration, custom constructor. After that we will write some constraints. Okay, see, so after that we are, in order to use the object field methods like compare, copy, pack, unpack, all these things we are registering. Okay, individually we will register, all the fields are registered to field macros. Okay, see how we are registering: utility and field macros. Okay, take object details begin, your class name. In between the begin and we are registering all the field macros. Take utils integer, your field name address all on, write enable all on, read enable all on. Okay, all these things we need to represent. And then custom constructor. After that we need to, we have any constraints, we can write the constraints. Okay, so either write or read operation we will perform at once. Okay, so the constraint is added to generate write enable and read enable. Okay, so if I am doing write operation, so write enable is 1. Okay, if I am doing read operation, read enable should be 1. That's why we are writing the constraint write enable not equal to read enable. Okay, if write enable is 1, read enable is 0. If read enable is 1, write enable is 0. Okay, so in that way we are doing the write operation. Then I am writing entire sequence item class. Okay, sequence item code. Okay, Okay, complete sequence item, memory sequence item code. Okay, class name extends from sequence item, and then data and control fields. Okay, data and control fields we are representing. After that we need to represent that, we need to register for that between the utilities and field macros. Okay, tick object details begin. So memory sequence item and field names, address comma all of. So if you want to write some hexadecimal, binary or octal, you can write here address comma hex, decimal, octal or binary. Okay, so in which format you want to store the data, you can write here. Okay, and then constructor. After that, constraint. This is the sequence item class representation. Clear? Same way, sequence. So sequence generate the stimulus and send to driver via sequencer. Okay, an agent can have any number of sequences. So I told you, right, read sequence, write sequence, read write sequence, nested sequence, burst sequence. Okay, complex sequences we need to design. Okay, all the sequences we have to generate here. Okay, so first one, the sequence is written by extending sequence. Okay, sequence we are extending. So class memory sequence extends sequence. Sequence we are getting the transactions. Okay, that is the parameterized class. Okay, hash memory sequence item. Okay, tick utils, tick sequence or utils. Okay, sequence or object, we can write anything. Okay, so memory sequence comma memory sequencer. Okay, so in that we can write memory sequence as the class name as well as sequencer also. Okay, sequencer is the carrying sequence items. Okay, whatever the generated sequence item, it will be carrying that. And then custom constructor, string name memory sequence super dot new name and function and class. This is the basic class registration of your sequence. And then, so next, logic to generate and send sequence items is added inside the body method. Okay, inside the body method we are adding the logic. What we are adding here? Same class extension. Okay, extends sequence. Okay, memory sequence item. Okay, pick objects, memory sequence, and then sequence item. Okay, so same thing. After that, so sequence item and then custom constructor. Custom constructor super dot function new string name memory sequence super dot new name. And then in body, virtual task body or task body we are considering. In body method we are creating the object. Okay. Request is the default handle. If you are not representing, not creating any handle, request it will take. Sequence item is the memory sequence item is the class. For that we need to represent some handle. Okay. If you are not representing, request is the default handle. Okay, request memory sequence item and then type ID create request. Okay, wait for grant. Who is waiting? Sequence. Sequencer will send the grant to sequence and then request dot randomizing the sequences and then send request. That means sequence items we are sending and then wait for item done. This is the basic handshake mechanism. Okay, so handshake mechanism based on that it will randomize the sequences and then send to driver. Okay, same way. Here I am doing write sequence as well as read sequence. Okay, write sequence how it is doing that. Same class registration. Okay, my class name extends from sequence. Okay, same thing. Memory sequence item we are writing and then tick object details memory write sequence. Okay, my class name is memory write sequence and then custom constructor. Okay, in that virtual task body tick do with. Okay, tick do, it is doing all the operations. Okay, creating and then wait for grant and then send items and then randomizing. After that, get response. Okay, all these items it will do the tick UVM do. So with is doing that some request. Okay, request dot write enable equal to 1. If you are doing any operation, we will go for with. Okay, so then here write enable equal to 1 means doing write operation. Similarly, read operation. Same way, read enable equal to 1 here. Okay, that's it. Understood? Okay, so this is all about sequence and sequence item. Okay.